Hello, ladies and gentlemen, and welcome and thank you for joining our session today and this case study. I'm joined here by Esben, as Holly mentioned, from Copenhagen Airports, and we are really eager to share some of the learnings with you that we have had over the last couple of years on this digitization journey that we have embarked on together with Copenhagen Airports. We have a packed agenda, so there's a lot of material to cover. And again, you're very welcome to questions at the end. And also, we are available afterwards for any questions you might have. So what we're going to cover today is, in reality, some of the learnings of the Copenhagen Airport situation before this journey started in reality. And Esben will jump in and share some of the challenges that Copenhagen Airports have had despite their ambitious digitization through the last years. And then we will touch upon our vision of smart airports. I know that has been a lot of discussion around this topic throughout yesterday and today. But we have our own vision of our own, let's say, definition that I think will surprise you, the answer to that. And then we have also a little bit of demonstration of what we mean when we talk about a truly smart airport and the data-driven airport. And then Esben will also share some a use case that demonstrates exactly that. See if I can change the slides. Here we go. So before jumping into the case, I just wanted to give you a little bit background of the context and why we are here today. So Smart Airports was founded a little over a year ago, and it is a joint venture between Copenhagen Airports and Netcompany, which is a technology vendor that you probably don't know. And this is important because it is actually some of the driving forces behind our visions and the mission that we are on. And Netcompany coming in as a technology vendor, I won't use much time explaining that, but really gives us the power and the ability to drive innovative development and having access to 3,500 plus highly skilled engineers, scientists, and developers to help us actually achieve the goals that we have set. We are based in Denmark, and we will come back into some of the things that we are doing together. But in reality, the force of this joint venture is simply the gathering of the best of IT, the best of implementation, the best of knowing how to leverage technology in the right way, combine that with the best of domain knowledge, which is Copenhagen, and really put that together to combine what's needed to deliver the best business value that we like to achieve through technology reality. And Smart Airports, we have two offerings. One is, of course, delivering SaaS service, the platform and everything surrounding that, of course, commodity. And on the other hand, as well, this is a legacy from our Netcompany background to actually ensure and take full responsibility of the delivering of the platform within airports to not leave anything behind unless the success is delivered as promised. So we are both a platform vendor and, of course, also a implementation partner for Copenhagen Airports. Before jumping into the specific that Esben will share with you, we've done a lot of research and analysis of the situation at Copenhagen Airports. And this is a way of illustrating some of the complexities and the challenges that Copenhagen were facing in their, what I call, a top-down approach. So any given system landscape, whether it was in the airport industry or elsewhere, can be divided into these three different layers of the stack, the system landscape. And Copenhagen Airports, being really an innovative and ambitious airport, have really been working hard on delivering business value despite the legacy and the problems that they had on the core platform, so the systems of record. So what I'm trying just to illustrate here is the fact that Copenhagen Airports many years have done a lot of innovation and built in smart features from the top down, but never been able to really change the foundation, the basic, the core data, as you can see here, or the AODB, because of the legacy platform and the technologies they were built on. And they reached a lot of good value from this approach. But as you can imagine, at some point you will reach a limit for how much you can do without actually touching the core data and the foundation in the bottom. So that limitations was reached, and that's why this empowered us, and it also gave the motivation to go forward with this digital journey by really digitalizing from the bottom up and taking control of the core data and the core platform in total. I'll get back to that after Esben has covered what this specifically looked like and some of the challenges behind this in Copenhagen Airports. Yeah. Esben.
Thank you, Mehdi. So in Copenhagen Airport, our current traffic system, the Copenhagen Airport traffic system, it really dates back to the mid-1990s. So it's between 25 and 13 years on its back as of right now. And internally in Copenhagen Airport, we sometimes refer to this system as the spider web, and hence the illustration here on this slide, because over the years, the system has been extended with new modules, new integrations, different technologies over the years, what was available at the time. So over the years, it has grown to become a spider web of different connections between the modules that form the Copenhagen Airport traffic system. Over the last 10 years or so, Copenhagen Airports have been on a digital journey. So we've added quite a few new functionalities and capabilities to our sort of landscape. I've shown some of them on this slide, like passenger flow management system, the ACDM system, a lot of passenger self-service solutions, resource management systems, forecasting systems, etc. And what you can see on the slide is that all these systems, they're able to pull data from the Copenhagen Airport traffic system. But what they also have in common is that there are no arrows pointing back. So we are not really getting anything of the value from the different systems you see around the core feeding back into the core. And in that way, we're actually missing out on a lot of the value that these systems create, because we are not combining this data in the right way, and we're not sharing this data with the other stakeholders. In fact, what we have done over the years, let me just see here, is that because we have had this old legacy system and we've been reluctant to do any changes to it because we know it's quite fragile. Instead, we have been building connections between these new modules, as you can see with the red arrows. So pulling data from the data warehouse or putting it there, or directly feeding data between these modules. And in essence, what we have done is to extend the spider web. So instead of solving the problem of having the spider web, we have actually been extending the spider web. Also partly because we were thinking there's a new traffic system right around the corner. So the problem is that while we've been doing this, we haven't really solved the core issues of the old system, in that we haven't been able to get real-time data, to get consistent and reliable data flowing between all these systems because of the limitations of our old traffic system. And a really good example of this is actually the current Corona situations. I'm sure many airports will recognize that all of a sudden there are brand new business processes, brand new way of handling the flights, handling the passengers, because some passengers had to be tested. Some flights had to be handled in a different way than they usually would be handled. And it was actually not possible for us to just go into our traffic system and add these new attributes or these new business processes or business logic. So instead, we've had to do quite a lot of workarounds, I would call it, simply just to keep the airport running during this Corona pandemic. And that really showed the issue, the fragility of our current system. So over the years, we have actually had several attempts of changing our own traffic systems. We tried ourselves. We tried with a third-party IT preventer, airport IT provider. Sorry. And none of that really succeeded. And this has led us to this 50-50 partnership with Netcompany, Smarter Airports, and now this AirHub platform that we're currently implementing in Copenhagen Airports. So back to you, Mehdi.
Thank you. And yeah, that was exactly the background and the motivation for us to continue this this journey. And back to this layered model, as I showed before. And I really didn't touch upon the three steps on the first slide because they were non-existing in an as-is situation. But now that we looked each other in the eyes and said that we need to fundamentally rethink and redo the IT landscape and the IT strategy, digitalization strategy in reality, in order to cope with these challenges, not for now, but also for the future. Because this is definitely a very key point, that we are not doing something to fulfill the current needs, but we know that we are moving into an era that will present us with challenges and needs that we don't know right now. So what we want to do is that we want to make sure, if I start from the bottom here, because that's the approach here from the bottom up, is to really have a solid risk-free system of record that can provide us the reliable data and the resilience we need in our core operation. And these should be, common standardized capabilities, as it mentions here, that doesn't require us to do changes and do development all the time, but we need to have, flexibility and stability without adding changes. We want to have a second level, the system of differentiation, where we can actually configure our way through the business needs that we have. And we need to be able to differentiate ourselves against others and have that defines us exactly for the airport that Copenhagen Airports is. And of course, being able to put smart features on top of that can enable all the business value that we know of today, but also may present themselves in the future. So in reality, what we want to do here is very important, to provide capabilities in the bottom and provide enablement at the top, because the smart features, we don't know what they are. We know some of them. We have some ideas of what could be done to optimize turnaround management or commercial or the passenger experiences, but the list is not final. So enablement at the top and standardized and that one source of truth in the bottom. And this is exactly what we set out for. And this bottom-up approach is exactly what is needed to rethink and challenge the status quo of platforms and IT infrastructure of an airport of the future. And that brings me to our vision of a smart airport and our definition of that. And I know that there has been many discussions throughout the day and yesterday of what is a smart airport. And we have these three different definitions or fundamentals in that definition that I would like to explain. So the first one being that smart airports need to deliver operational excellence. This is in reality, maybe not today, but it should be a commodity. We need to have full trust in that bottom layer that I mentioned before, with all the capabilities needed to deliver an efficient and risk-free and stable operation of the airport. That is to capture, validate, handle flight data and all the processes related to that, and all the capabilities that we know we need to have enabled to do that. So that is a commodity, as I mentioned, and we need to have those capabilities in order and a stable platform to deliver that. This next thing, here we start with the capabilities and the enablement again. So what we see in a smart airport is that we can cope with the ecosystem that an airport has. all the different stakeholders, all the different data endpoints that we need to collect and provide a structured and uninterrupted flow of data throughout this ecosystem. We must be able to deliver that so we can put down the silos and have a holistic and connected ecosystem throughout the airport. And that is new data sources, that is data sources that we know today, for example, IoT data sources, whatever, but it can also be data sources of the future that we don't know of, being able to cope with that, as adapting to the unknown in reality. And also to provide this one source of truth for the entire ecosystem. So you don't have to go to different endpoints to get information that you think you need, or you need to be able to deliver the business value that you're looking for to deliver as any stakeholder. The last part of this is what I think is the most important, is that we've all heard about data and collecting data, having a lot of data, but data in reality it has no value unless it is put to work. And enabling airports to actually power data to work for them and use intelligent future machine learning or in reality analytics or logic tools to work with this data, that is the essential. So what we want to do is make sure that we can leverage the data to, one, optimize on the first one, operational excellence. So use data to optimize on turnaround management and efficiency, but also to use data to create new opportunities, as we have heard of many examples of throughout the day, as passenger experience. That can be, safety and touchless experiences, or commercial experiences that might be, relevant for that airport. So this is how we see our vision for smart airports, is to have the operational excellence in order and have enablement to put all of these smart features on top of that. And a lot of talk, and I've heard many talk about open flexibility, but actually going one step back here to this slide, there is one factor here that is very important, which leads me to the next, is that everything that we've built here is based on modern technology. So the last code, or the oldest piece of code in this platform, is from 2019. So it is built on the best principles of some of the best technology vendors out there, providing SaaS platforms as Salesforce, Microsoft, Amazon. So the opportunities we have to actually put capabilities behind these concepts is much further ahead than many in the industry. And that brings us to an area where I want to exemplify how that modularity, the flexibility in the ecosystem looks like in a modern platform as we have here. And for that, I have a video from my colleague that I will play for you.
Hi, this is Bjarti from Smarter Airports. In this video, I'll introduce you to Airhart's Data and Assets tool, which is a powerful yet user-friendly tool for creating and managing master data. The underlying principles are actually quite complex, but our focus has really been to create a user-friendly interface that allows non-technical users to understand and work with the data that's relevant for their role. For the example I want to show you, we'll go to countries and find Denmark. We're now presented with all the information registered on this particular country. In Airhart, all entities are saved as versions with a specific validity period. This is because we use a bitemporal data model that allows us to edit data without losing track of how it has changed over time. For Denmark, we currently have just one version, starting from 1990 until infinity. But let's just imagine that we know that in some point in the future, this data needs to be changed, and we want to act upon it already today. We simply copy the current version set a new validity period, and make our changes. When we save the version, the timeline changes, so the new data is only applied to the period we have specified. In the background, AirHeart will now reprocess all flights affected by the change, so they're handled correctly depending on their operation date. If changes are sensitive to safety or business, AirHeart also has a built-in approval process where changes are only published once they have been reviewed and approved. If we go a step back, find country again, we can click Edit Entity. This will open a 6-step wizard giving us complete control of all aspects related to the country entity. On step 1, we can set up general things such as name, description, and category. Step 2 allows us to configure the attributes that we want to be part of the country entity. Depending on our needs, we can configure many attributes with complex validations and advanced references, or we can just add a few simple attributes. To add a new one, we simply find the type we need and drag it in. We can basically add anything we want, but let's say we're interested in having data for each country's COVID category, with options A, B, or C. The next step allows us to preview our attributes, and we can see that the new COVID category has been added. Now we can configure default table display, uniqueness constraints, and finally the naming pattern. We're now ready to submit, and with a click of a button, our data model has been extended with a new attribute that's instantly available to business rules, logic flows, and alerts. No coding or deployment needed. If we instead wanted to create an entirely new entity, we would simply click the Add New button and go through the exact same steps as before. Simple, flexible, and powerful.
Thank you for that. And this exemplifies exactly what we are trying to do with the flexibility and the modularity of the platform, to enable the business to do the changes needed for now, for the future, without having to involve IT and have long, prolonged development phases to be able to cope with the changes that a business needs to cope with. This is a very small example of that flexibility, and if you're interested, of course, we can share some more in a live demo. But I will give it over to Esben now, who will actually try to go over an example of how this flexibility actually comes into value.
Yes, thank you, Mehdi. On my screen now is a simplified architectural drawing of the entire AirHeart platform, and I won't go into all the details, but just talk briefly about how we structure the different modules of the platform. On the left-hand side, you see examples of different data sources that can be input into the system. All relevant data sources for the airport operation could, in principle, be added to the AirHeart system. In the center of the drawing, we have the AirHeart core. And as mentioned before, one of the core features here is the matching and enrichment engine. This is where we collect and store all the different data sources and ensure that we have this one version of the truth, that the data will be enriched with all the master data that we might have, and ensure that we have the same data that we then provide to all the different other stakeholders that we have in the ecosystem. On top of the core, we have the user interface, and we might have several different stakeholders that are all accessing the same user interface, so we ensure the same look and feel in the user interface here. And based on the different roles and their different security settings, they can see different parts of the data, obviously. And then on the right-hand side, we have third-party components. It could be IoT systems, it could be resource allocation system, where we want to feed data and we want to receive data back into the core to make sure that we get the most value out of that. And as Mehdi mentioned, we wanted to do a very specific example. So let's assume that we have a step one. Here it goes. That we're integrating with a vision tech platform. It could be we're using cameras on the aircraft stand to detect the different events going on in the turnaround process. First of all, we need to ensure that there's an integration to this platform. Of course, we need to send the flight information from the AirHeart platform. And what we want to receive back from such a system could be all the events that are detected out there, such as the catering has started or the fueling has started and ended. So that's sort of the technical integration that will be set up using the standardized APIs that are in the platform. But once that is done, it's actually up to the business user, as was just demonstrated in the video, to make the necessary changes, because now we're actually able to go in and adjust our flight entity and then add new fields, new attributes for the data that we're starting to receive, such as fueling has started or the timestamp when catering has started, etc. And as was demonstrated in the video, this can actually be done by the user. Once we have amended the different entities, we're actually able to start using this data. So we can adjust the different lists that we have, the different layouts and so on, and simply add this new data to show to the different users. The next step then is to go into the core really and adjust some of our business rules, because now we've started collecting this data, we can also build business rules around it. These might be very simple rules saying that, you know, if catering is delayed by more than 5 minutes, we raise an alert, we show a visual cue. But it can also be more complex business rules that if this happens, then something else in the system needs to happen, or even send out a trigger to one of the third-party components. It could be a resource management system to tell, because this event is now delayed, something needs to happen in terms of our resource planning in some other systems. If there is a user interface, in this case, it could be the cameras, the live videos from the cameras. We could also integrate that into the platform in the unified user interface and embed that video so that the user doesn't have to go anywhere else to see that information. And finally, with this example, we can also use, of course, this data now to do predictions, to use the machine learning built-in capabilities that we have in the AirHeart platform. We call it our insights module. To better predict some of the events that will take place. And as an example, if we start detecting all the different sub-events that take place in the turnaround process, we might actually, for instance, be able to better predict the first back times of the arrival process. Instead of simply predicting them based on the on-block timestamp, if now we know exactly when has the baggage offloading started, when is the first delivery van going back to the offload area, we will be able to better predict the actual first back times for the passengers and also for the resource allocation of our racetracks. So that is a very specific use case of how we can integrate data, combine it with all the other data in the core of the platform, and then providing this data in the user interface and to other third-party components.
Thank you. Thank you. And that actually concludes our session. And there was a couple of minutes for questions. One last statement is that what we're trying to do, and the vision we have here, is that the platform is developed by airports for airports. So we have the right knowledge of the domain in the work that we do, is developed by the best engineers. So the technical foundation is in order. And lastly, but at least as important, by data science that know that the data we have is the right condition to be able to do the predictions as mentioned. And that is essential, what we think is needed for smart airports of the future, to be able to connect and use that data intelligently in the future.